Okay, so in this video we're talking about independence of events, which is when one event occurs, it doesn't affect the probability of the other. Basically, if I have information about one thing happening, I still just don't have any information about the other. They are completely independent. They do not affect each other. So if we have we know something's independent when P of A intersect B equals P of A times P of B. So if you recall in the last video where we went over conditional probability, we had this expression, the probability of A happening given B already happened equals the probability of A and B intersect over the probability of B. Well, what's interesting is if we were to substitute P of A intersect B equals P of B times P of A into this expression, we see that the P of B's cancel. We're just left with P of A given B happened just equals P of A. Basically, even though this separate event B happened, the probability of A is still just the probability of A. This is only true when two events are independent. So for example, if I had two cases, A and B, A being I skip class, which I would never do because this class is bomb, but say the probability of me skipping class is 5% or 0.05. And the probability that it rains is 10% or just 0.1. If the probability of me skipping class and it rains on the same day is 0.005 or 0.5%, then A and B, or me skipping class and it rains, is independent. Which would make sense because there is no feasible way that me skipping class, being in a different position at a different time on Earth, would affect the atmosphere up above. So it's safe to say that me skipping class and it raining are independent. But I do want to clear up one more thing. Independence of events is not mutually exclusive. So, say I had a coin. The probability of me flipping heads is just 1/2. And the probability of me flipping tails is 1/2. But the probability of both of them happening is 0. Because I cannot flip a coin and get both heads and tails at the same time. If we were to draw with this Venn diagram, they are completely exclusive from each other. But that doesn't necessarily mean independence. Independence implies that there is a probability that both of them can happen at the same time. So all in all, independence of events is, given that they can happen at the same time, one event occurring does not affect the probability of the other.